All right. Question 1 is about Taylor series approximation. 2 is about computing gradient and Taylor series approximations. 3 is about 3 by 3 matrix determinant. 4 is about integration. 5 is about moments of truncated normal distribution. Okay, let's start with question 1. How would you approach question 1? Okay, which formula? You can unmute and then talk, because which formula is it? Yeah. Oh, I have computed this using Mathematica. That's just for me, just to check it.
Hello, hi there.
Hi, how are you?
I'm good. How are you?
I'm good. Thank you. Yeah, how would you use, which formula are you gonna use?
Just Taylor, the sum of fn of a on n factorial times x minus a to the n.
All right. Okay. What would be your first term?
This one has only two derivatives, right? There's no third order. The first question. There's a log. I didn't see the log. So.
Yeah, that's a lot. Can you start with the derivative of ln 1 plus x squared as it is?
Yeah, just 1 plus x squared. You take the reciprocal, then times 2x.
And then you expand it about x equals 0. What happens?
You use f0 instead of you take the derivative and evaluate at x equals 0.
Yeah.
This one should be quite mechanical. Just plug in the formula and expand and find the pattern, and that will be the Taylor.
All right. Let me share what I did. Okay, yeah, this is the, actually, because we are expanding around x equals 0, that's Maclaurin series. And the formula for Maclaurin series is this one here. At first, I've considered effects. Fx equals ln 1 plus x, or 1 plus y. You can say 1 plus y. Then the first derivative, take the first derivative, which is 1 over 1 plus x, goes and evaluated at x equals 0, which is 1. Second derivative evaluated at x equals 0, which is minus 1. Third derivative is evaluated at x equals 0, 2, and we go on until fn 0, which is at x equals 0, which is equal to minus 1 to the power n plus 1 times n minus 1 factorial. Therefore, ln 1 plus x can be given by this series here. And simplifies to that part. Okay, now replace x with x squared. We get and expand in sum of the terms. I got x squared minus x to the power 4 over 2 plus x to the power 6 over 3 minus x to the power 8 over 4. Okay, and goes on. And to test for convergence, you could use ratio test, which states that sum of a n goes from 1 to infinity, is absolute limit as n tends to infinity, absolute value of a n plus 1 divided by a n, converges if the limit is less than 1, diverges if it's bigger than 1, and if L is equal to 1, inconclusive. So computing the ratio a n plus 1 divided by a n, I got this part here, which simplification gave me which is x squared, and absolute value of x squared, you can simplify that to square root of x squared, which is absolute value of x. So the series converges for x between minus 1 and plus 1. All right. That's the first question. And for the second question, I wouldn't show you the question. Okay, but I'd like you guys to start with the question. You're given so x in this case is x1, x2, and f of x equals x1 plus e power x2 minus x1. First part is, what is the gradient of x? How would you find that? How would you find the gradient of it?
I'll just take the partials.
Yeah, take the partial derivatives, which would be dx1 of your fx and dx2 of your f of x. which is equal to what's the derivative of f with respect to x1? Derivative of f with respect to x1. That's the partial derivatives. What's that? Can you hear me?
Yeah.
All right. What would be the derivative?
X1.
Yeah, with respect to x1.
1 minus e to the x2 minus x1.
Yeah. Thanks, Kai. The second one, partial
E to the x2 minus x1.
Sorry.
E to the x2 minus x1. Here's the second term.
Yeah. Okay. Question part B upset, use this derivative to find the Taylor series approximation. Approximation of fx about 1, 2. So x1 is 1, x2 is 2. You can use up to order 1. Okay, just the first two terms. How would you write this?
The first term oscillates, right? There's a minus.
Sorry.
The first one oscillates means the first derivative will be plus, and the second one will be minus, and plus minus. It goes on. Because there's the coefficient of x1 is -1. So you take that down.
Yeah.
So it becomes x2 minus x1 for the first derivative. Then the second one will be plus, third one. The second one will be minus, and the third one plus, minus, plus, minus.
Okay, so the first term would be f of 1, 2 plus f of 1, 2, and then this would be x minus 1, 2, okay, which is equal to f of 1, 2. You can which would be like evaluating f at these two values. I got that is 3.7 183 plus this one gradient f 1, 2, which would be 1 take equal so it's 2 minus 1, which is right. So that in numerically, when you evaluate, what that is minus 1.7183, 2.7183. Suppose this is x1, x2 minus 2, equal to 3.7183 plus or minus 1.7183. You got x1 minus 1 plus 2.7183 2 minus 2. Right. So that's the Taylor series approximation to the first order. Okay, any questions? No? Question 3 is about, you guys have the questions with you, right? I just shared it in the chat. Have a look at the questions. Question 3 is about 3 by 3 matrix determinant. A equals, let's say you got 7, 0, negative 3, 2, 3, 4, 1 minus 1 minus 2. And what's the determinant of A? How do you put this? Can be also written as. What would be your approach? Yeah, what's that method? Anyone else would like to add? What's this method called? You would be using cofactors. Okay, so if that's I 1, 2, 3 and J 1, 2, 3, rows are I's, columns are J's, and then using the cofactor method, that's minus 1 times. If I expand along the first row, that would be minus 1 with 7, and then determinant of, ignore the first row in the first column. What's remaining is minus 1, minus 2, and plus minus 1 this time. Sorry, this is first row, first column, first row, second column. The value is 2 here, and determinant of, ignore the first row, second column. What's remaining is 0, minus 2, minus 1, minus 2, and plus minus 1. First row, third column, the value is 1. So it's 1. Determinant of, ignore the first row, third column. What's remaining is 0, minus 3, 3, 4. Okay. And is equal to minus 1 to the power 2, which is plus 1, so it's 7. Determinant of the 2 by 2 matrix. For 2 by 2, you have A, B, C, D. It is AD minus BC. So using that formula, you have 3 times minus 2 is 6 minus minus 1 minus 4 minus 1 to the power 3, which is minus 1, so it's 2. 0 minus 3, that's plus 1, 0 minus minus 9, which is 7. Did you get that? Is there any question? Yeah. Is that what you got? No? Yes? Okay. Next question is about integration. You are asked to integrate equal x sin x dx. How do you approach this? Yeah, by parts. You remember the formula? What's by parts formula? You derive it? All right, that's good. U dv is equal to uv minus v du, all right? So we can say in this case, u equal so du is equal x dx, and v is integral of sin x dx. What is that? What's integral of sin x? Yeah, minus cos x. So that means sin x dx is equal to u times v minus v x cos x minus okay. Now what do we do? How do you simplify this? you can again use by parts here. Again, u equals x, du equal x dx, and so v is integral of cos x dx, which is equal to, what is integral of cos x? Sin x. So that's to minus equal x, plus okay. Now that's equal x sin x dx. Oh, I made a mistake. So you got the same term here, which you could collect together, and that's 2 equal sin x dx, is equal to minus 4x plus x plus x sin x equals to half okay, plus a constant term. Okay, any questions? Any questions? Okay, last question is about moments of truncated normal. Okay. Okay, you are supposed to show that if x is normal with mean mu and variance sigma squared, where x is between A and B, that's why it's truncated normal. Okay. It's not on entire line, but between A and B. Okay. Let mk be the kth moment, which is the expected value of x to the power k. And then you are asked to show that part here. Mk is k minus 1 sigma squared mk minus 2 plus mk minus 1 minus sigma, where this function is the PDF of standard normal, and this is the CDF of standard normal. Okay, with m minus 1 is 0, m0 is 1. Okay, remember that for the standard normal, mean is 0 and variance is 1. Okay. How would we proceed to do this? Okay, and PDF of standard normal is given by this part here, and CDF is this part. What's your thoughts? It's okay if you get wrong. Okay, how would you start then? This is a function of the random variable. So in general, if you have G is a function of X, okay? If X is a random variable, then expected value of G of X is equal to, if X is continuous, which is G of X, fxx dx. Okay, that's in general. So we are gonna need that. Yeah, find that we are gonna need the definite integral. Okay. How would we start? You can start by defining, let's say, a node equals the probability of X between A and B. Which implies a node is equal to the characteristic function, okay? Because that gives you A and B of your which is equal to AB of 1 over square root of 2 pi sigma e to the power minus half 2 sigma squared x minus mu squared dx, which is equal to the characteristic function of normal b minus mu over sigma and minus a minus mu over sigma. Okay. Starting with that, we have mk and naught, which is equal to AB x to the power k, because remember mk is expected value of okay. So that's x per k, and we have in terms of writing this as standard normal, standard normal is 1 over you need to scale it by sigma, which is equal to right. Then what I did was from this step, I said x to the power k can be written as k minus 1, 1, and then and sigma over sigma, and then there is two pi e power minus which is equal to AB k minus 1, and then you got x over sigma squared. This can be written as x minus mu over sigma squared plus mu over sigma squared. This is equal to okay, expand in this bracket, we get times minus x minus mu over sigma squared e to the power minus x minus mu 2 sigma squared dx plus this is equal to this is using by parts. Okay. Right. Yeah, this is a very lengthy computation. Now you need integration by parts. Yeah. Okay. I think the assignment question should be much easier than this one. For the assignment, did you use integration by part? All right. Okay, is there any question? Is there any question for those who have not submitted their assignment? Do you have any difficulties? Because when I update this notebook, I can consider that. That's a good question, but I need to figure that out. Okay. Okay, Kai, I can give you a breakout room. Yeah. So,